Intermediate Algebra for Statistics, Using Graphs and Tables to Solve Systems, Part 2. Lesson Objective: Use a graphical approach to solve systems of linear equations. We'll begin with an example. Example 6. Solve the system 1/2 x plus 5/4 y equals 5/2 and y equals 3x minus 4. Solution: we graph the equations. We need to put the first equation in slope-intercept form. So to solve for y, we're first going to get rid of the fractions. So we're going to multiply all the terms in the equation by 4, the least common multiple between 2 and 4. So 4 times 1/2 is 2, so we're left with 2x. 4 times 5/4, the 4's cancel, we're left with 5 times y. And 4 times 5/5 is the same thing as 10. Next step, to solve for y, we subtract 2x to both sides. So we're left with 5y equals negative 2x plus 10. Now divide by 5, we have y equals negative 2/5 times x plus 10 divided by 5, which is 2. So if we sketch both these on a coordinate plane, here we have the equation y equals 3x minus 4. The y-intercept is negative 4, and the slope is 3/1, which is 3. For the blue line, the y-intercept is positive 2, and the slope is a negative 2/3. So we go down 2, to the right 5. And we see where these two lines intersect, it's not integer numbers. So we would say it's approximately 1.8, 1.3. Now this is one of the limitations by solving a system by graphing, is sometimes we do not get exact answers, we get estimates. Using the intersect feature on the graphing calculator, we can take this to more decimal places if needed. To verify this solution, we take our equation, we substitute our values in. I'm taking this to 2 decimal places, and we see rounded to 2 decimal places. These are pretty close. For the second equation, again, we see that these are pretty close, so we have verified our answer. So again, if we need this to be more precise, we can use the graphing calculator. We put the expressions in, the y equals, and we use the intersection feature, and we can take x and y to more decimal places if needed. Using two models to make a prediction. Example 7. In the United States, life expectancy of women have been longer than life expectancies of men for many years. Life expectancies in years for women and men are given in the table below. So here we have the year of birth. Here's the life expectancy measured in years for women, and here's men. Using this data, find the models for the life expectancies in years for women, denoted W of t, and men, denoted M of t, where t is the number of years since 1980. Round the slope to 3 decimal places and the y-intercept to 2 decimal places. So our independent variable is going to be t. So our t variable will be 0 here, 5, 10, 15, 20, and 23. So we're going to use the graphing calculator. Put our independent variable in list 1. We'll put the women in list 2. Put the men in list 3. So we hit stat on our graphing calculator, and then enter for edit. List 1 will be t. List 2 will be the life expectancy for women. List 3 will be for men. Once you have the data entered in, next you press stat, then use your right arrow key and go over to calculate, then number 4, linear regression. Paste this into the home screen. Now normally we could hit enter, but we could also type list 1 comma list 2. That's the default. Now the reason why I'm doing that is we're going to do list 1, list 2 for the first model, and then we're going to do list 1, list 3 for the second model. Once you hit enter, to type in list 1 in your calculator, you simply hit second, then number 1. For list 2, you hit second and number 2. Hitting enter, we have the model. A is our slope, B is the y-intercept. So we can say W of t equals 1.05 t plus 77.53. So this is the model for women. For men, we hit the stat button, then we move it to calculate, then number 4, linear regression. Then we want to hit second number 1 for list 1, comma, then second number 3, which is list 3. Hit enter, and this is our model. So we can say for men, M of t is 0.203 t plus 69.91. Now we want to find when is the life expectancy for men and women the same, or in other words, when will these two models intersect. So we hit our y equals button, we type in the first model for women, the second model for men. Now if we press graph, both these models will be outside the viewing window. To determine the viewing window for the graph, we need to estimate where these two lines will intersect. One way of doing that is using the table feature. So if I hit second and graph, that's the table, and here we can see we have list 1 and list 2, and instead of starting at 0 and counting by 1, let's hit second window, which is table set. So instead of starting at 0, we'll start at 50, and we'll have the table count by 5. So then we hit second and graph again. The table now starts at 50 and goes to 55 to 60, and what we're looking for is when y1 and y2 are about the same value. So as we scroll, here we see at 75 we have an 85.4 and an 85.13, then we have an 85.9 and an 86.15. So it's somewhere in between 75 and 80. So next we hit window. I'm going to change the x-min to a -5 and the x-max to say 100 or 110. So that way between 75 and 80 is going to be in about the middle of the window. I'm going to have the x scale be 5, so it's going to count by 5. Now since the y-intercept for women was about 77, I'm going to set the y-min to about 75 and the y-max to about 90, and I'm going to have the y count by 2, and I'm going to hit graph. And here is my graph with my window settings. We can see this point here is the point of intersection. Now I'm going to let the calculator determine that by using the intersect feature. So if we hit second and trace, which is calculate, go to number 5, intersect, it's going to ask me for the first curve. It's on this line, so I hit enter. Then it asks me for the second curve, and it jumps to the second line. I hit enter. Then it asks for the guess. I'm going to scoot this to this intersection point, hit enter, and the calculator returns that the intersection is about 77.76 and the y is about 85.69. So we're going to round this to 2 decimal places and say that the intersection point occurs at this point. So here we have the visual of the graph from our calculator. This is the point where these two are equal according to our models. So what does this mean? This means that the life expectancy for men and women will be about 86 years in the year 2058. That is 78 years from 2000. To verify this numerically on the graphing calculator, we start at our home screen. We want to hit the vars button, which is short for variables. Then we want to use our right arrow to Y vars. The first choice is function. We hit enter. The first choice is Y1, that would be the female model. We hit enter. Then we want to type parenthesis 77.76. Now this is our X value for the intersection point, and we get a Y of 85.69. To do the males, we hit the var key, scoot it over to function. This time we want Y2, hit enter, then type in parenthesis 77.76, the X value, and the Y value turns out to be about 85.69. So we have verified this numerically using the graphing calculator. Intersection point of the graphs of two models. Property: if the independent variable of two models represent time, then an intersection point of the graphs of the two models indicates a time when the quantitative represented by the dependent variables will be equal. Thanks for watching.